So let's do some examples where we have to use the exponent rules. So the first one I have for you is 2 to the 5th times 8 to the 5th times 16 to the 3rd. So what we have here, they don't have the same base, but they do have the same exponent, so I could combine those. And if I do that, I could combine that with the 16th. So just keep in mind that with any problem that we do, there's so many different ways to do it. So this is not the only way to do it, and you'll end up at the same result if you do it any other way, as long as it's within the realm of mathematical properties. So first off, they have the same power. So what that means is I can multiply those two. So I'm going to do 2 times 8 to the 5th power. And then I still have 16 to the 3rd power. So when I do this, I get 16 to the 5th power times 16 to the 3rd power. Now I have the same base, so I can add the exponents. So it'll be 5 plus 3. So I get 16 to the 8th power. But if I wanted to have it in primes, powers of primes, 16 is not a prime number. But I know that 16 is 2 to the 4th power, and we can say instead of 16 we can write 2 to the 4th, but we still have to the 8th, right? And when we have powers of powers, we multiply. So this becomes 2 times 4 times 8, which is 32. Okay, and we're pal. Oops, that's supposed to be a U and a period. Okay, and the next problem that I have for you is 9 to the 4th divided by 3 to the 7th. First off, the only thing with division that we know is when we have the same base, we can subtract the exponents. So that's going to be our goal. So 9 can be written as 3 squared, right? So instead of 9, I can write 3 squared to the 4th divided by 3 to the 7th. Powers of powers, I multiply. So 2 times 4 is 8. And then it's a division, so I'm going to write it as a fraction instead. It doesn't really matter which way you show it. But we have a 3 and a 3. So the bases are the same, and we subtract the exponents. So it's 3 to the 8 minus 7. So we just get 3. And we are pals.